Hi, in this video we are going to discuss one of the most important topic in chemistry, which is difference among pH, Ka and pKa. pH tells what happening in the solution and Ka and pKa tells what the really acids are at molecular level. Two different acid solution may have the same pH but the different Ka and pK values. Let us learn the deep concept about pH, Ka and pK values. pH. pH tells the number or concentration of hydrogen ion, hydronium ion or indirectly hydroxyl ion in 1 liter aqueous solution. If an acidic solution have more hydroxyl ion as compared to hydrogen ion or hydronium ion, then the pH will be higher and the acid strength will be lower. In fact, pH is the negative log of hydrogen ion concentration. They simplify the number of hydrogen ion or concentration of hydrogen ions in 1 liter aqueous solution. And pH depends on the concentration of hydrogen ions. For example, 0.01 molar hydrochloric solution and 0.001 molar hydrochloric solution have different number of hydrogen ions as well as different pH. Hydrochloric acid is a strong acid. When we dissolve 0.01 mole of hydrochloric acid in 1 liter aqueous solution, it completely dissociates and gives 0.01 mole of hydrogen ions and 0.01 mole of chloride ions in aqueous solution. Now we can simplify the number of hydrogen ion concentration by taking negative log of hydrogen ions. And we can convert 0.01 to 10 power minus 2. Now, by solving negative log, we can find out the pH of 0.01 molar hydrochloric solution, which is 2. Similarly, we can find out the pH of 0.001 molar hydrochloric acid in 1 liter aqueous solution. Being strong acid completely dissociate and gives pH 3. Other all strong acid like hydrochloric acid, sulfuric acid and nitric acid, these all strong acid completely dissociate in 1 liter aqueous solution. And we can find out their pH directly by taking negative log of hydrogen ion concentration. While on the other hand, weak acid, for example, 0.1 molar and 0.01 molar acetic acid in 1 liter aqueous solution do not completely ionize and do not give equal number of hydrogen ions. So, we cannot find out their pH by taking negative log of hydrogen ion concentration or by using direct formula. For example, when we dissolve 0.1 molar acetic acid, at initial time there is only 0.1 molar acetic acid. And at equilibrium, X mole of acetic acid dissociate and form X mole of hydrogen ion and X mole of acetate ion. And as we know that K is the ratio of concentration and this is specific or constant. For acetic acid, this is 1.8 cross 10 power minus 5. Here, X is the concentration of hydrogen ions which actually form. Now, as we know that K is the ratio of concentration of product concentration of reactant, we can find out the value of X as we know the Ka value of acetic acid. Here we neglect only X. This is very little amount as very little amount of the acetic acid dissociate. Now by simply putting the values, we can find out the value of X, which is the concentration of hydrogen ions at equilibrium. This comes 1.36 cross 10 power minus 3. This is actually acetic acid dissociate and form hydrogen ions concentration at equilibrium. Now as we know the concentration of hydrogen ion, by taking negative log of this concentration, we can find out the pH, which is 2.78. This is the pH of 0.1 molar acetic acid in 1 liter aqueous solution. Now, similarly, we can find out the pH of 0.01 molar acetic acid in 1 liter aqueous solution. As we know the initial concentration value and Ka value, we can find out the value of X. By simply solving equation, we can find out the value of X, which is actually the concentration of hydrogen ions. This comes 4.24 cross 10 power minus 4. Now, as we know the concentration of hydrogen ions, by taking a negative log of this concentration, we can find out the pH, which is 3.37. This is the pH of 0.01 molar acetic acid. So acids having different concentration with equal volume have different pH. If the concentration is higher, pH is lower and acidity of that acid will be higher. Let us now we discuss the K value. This is actually tell the acid strength at molecular level. This is actually dissociation strength of an acid molecule. And dissociation is directly related to acid strength. If the Ka value is higher, then the acidity will be higher, as that acid will dissociate more and will form more hydrogen ions. Actually, K is the ratio of concentration of product to concentration of reactant. This is ratio which is specific for each acid. This does not depend on concentration. For example, 0.1 mole and 0.01 mole acetic acid have same or constant Ka value. Every acid have constant or fixed this value. Let us now we find the Ka value of these two concentrations. As acetic acid is a weak acid, this does not dissociate completely. At initial time there is only acetic acid, and at equilibrium X mole of acetic acid dissociate and form X mole of hydrogen ion and X mole of acetate ions. Now by formula we can calculate the value of Ka. Here X is the concentration of hydrogen ion which we can find out through pH. As we know that this is the negative log of hydrogen ions concentration, we can rearrange this equation and can write it as. This is the rule that log is the reverse of power 10, so we can write it as. Now by putting the value which we have calculated, we can find out the concentration of hydrogen ion, which is 1.35 cross 10 power minus 3. Now by simply adding the value of X or the concentration of hydrogen ions, we can find out the value of Ka. By solving this equation, we can find out the value of Ka, which is 1.8 cross 10 power minus 5. This is the Ka value of 0.1 molar acetic acid in 1 liter aqueous solution. Now similarly we can find out the value of Ka for 0.01 molar acetic acid in 1 liter aqueous solution. As we know that Ka is the ratio of concentration of product to concentration of reactant at equilibrium. Here X is the concentration of hydrogen ions, which we can find out through the pH formula. Now we rearrange this equation, and as we know that log is the reverse of power 10, so we can write this equation as it. Now as we have calculated the pH value of 0.01 molar acetic acid, by putting this value we can find out the value of hydrogen ion concentration, which is 4.17 cross 10 power minus 4. This is the molar concentration of hydrogen ion in that aqueous solution. Now by simply adding the value of X or concentration of hydrogen ions, we can find out the value of Ka. By solving this equation, the value of Ka comes again 1.8 cross 10 power minus 5. So when we have the different concentration of an acid, the value of Ka is the fixed or same. This is constant value. The K value of strong acids are infinite. For example, when we dissolve 0.1 molar hydrochloric acid in 1 liter aqueous solution, here at the time of equilibrium, all the hydrochloric acid associate and form hydrogen ion or colloid ions. So there is no concentration of hydrochloric acid. No, as the K is the ratio of concentration of product to concentration of reactant, and here the concentration of reactant is 0. but we can find it through other methods. pKa value. This simplify Ka value. If an acid have pK value higher, its Ka value will be lower and the acidity of that acid will be lower. In fact, pK is the negative log of Ka value. As the value of Ka for 0.1 mole and 0.01 mole acetic acid is fixed or constant, which is 1.8 cross 10 power minus 5. So the value of pK is also fixed for an acid and does not depend on concentration. For example, for acetic acid we can calculate the pK value by taking a negative log of Ka value, which comes out 4.74. pH and pK values are different, but when the concentration of weak acid and the concentration of the salt of that weak acid are equal, at that point pH and pK values are same. For example, when we mix 0.05 mole acetic acid, which is a weak acid, and 0.05 mole of acetate or sodium acetate, which is the salt of that weak acid, in 1 liter aqueous solution, this make a buffer solution and have the pH and pK value same. We can convert 0.05 mole acetic acid to its gram, which are 3 grams. And we can also convert 0.05 mole of sodium acetate to its gram, which are 4.1 grams. So by mixing 3 gram of acetic acid and 4 gram of sodium acetate in 1 liter aqueous solution, this make a buffer which have the same pH and pK value. This is according to Henderson equation. pH and pK value are same when the concentration of salt and acids are same. Let us compare the strength of different acids by their dissociation constant and pK values. For example, there are 4 acids having Ka values from 10 power minus 5 to minus 2. And their pK values are 5, 4, 3 and 2. Now, the strength of first acid is moderate. Second acid is 10 times stronger than first one. Third acid is 100 times stronger than first one, and the fourth one is 1000 times stronger than first one. So when K value increase, pK value decrease and the strength of acid increase. Thanks for watching and please comment if you have any question.